Example, a boat traveled downstream a distance of 95 miles and then came right back. If the speed of the current was 8 miles per hour and the total trip took 6 hours and 20 minutes, find the average speed of the boat relative to the water. Okay, before I do anything, I'm looking at the time that I'm given, 6 hours and 20 minutes. Notice that the speed that we're given is in miles per hour. It's important that we stick with the same unit of time, hours. So we need to convert minutes to hours. So the way that we can do that, if I look at 20 minutes, and you may do this a shorter way, but I just want to give you a method that will always work. Since we want to end up with hours on the top, we want the minutes to cancel out, so that's going to be on the bottom. We know 1 hour is equal to 60 minutes. So if I multiply this out, the minutes are going to cancel, and I'm left with 20 over 60 hours. And that simplifies to 1/3 hours. Okay, so that's 6 hours and 20 minutes is equal to since this is 6 hours plus 20 minutes, it's 6 hours plus 1/3 of an hour. That's going to be 6 1/3 hours. Now we don't want to work with that mixed number. It's easier to work with an improper fraction. So we do 3 times 6, which is 18, plus 1 is 19. So we have 19/3 hours. Okay, so we got rid of that off the bat. Okay, well we are trying to find the average speed of this boat relative to the water. Okay, so let's write a table to kind of summarize what we have. All right, and I'm going to put a little arrow here so you'll know that this is the same thing as that. Well, hopefully a formula came to mind that would apply to this problem, and that's distance is equal to rate times time. So in our table, we're going to have columns for distance, rate, and time, and we're going to fill in what we know and what we're looking for. All right, so let's read back through the problem and fill in our information. So we have a boat that's traveling downstream a distance of 95 miles. So my first row, I'm going to put downstream. And we know that the distance is 95 miles. And then came right back. So if he goes the opposite direction, that means he's going to be traveling back upstream the same distance of 95 miles. If the speed of the current was 8 miles per hour and the total trip took that amount of time, find the average speed of the boat relative to the water. Okay, so let's let R represent the speed of the boat. So since our boat was traveling downstream, that means it was traveling with the current. So the current's going to push it along faster. So if R is the speed of the boat in still water, and the speed of the current is 8 miles per hour, when the boat was going downstream, its speed would actually be R plus 8 miles per hour. When the boat turns around and goes back upstream, it's going to be going slower because it's going to be fighting that current. So you would take the speed of the boat and you subtract the speed of the current, 8 miles per hour. Okay. So now we know that the total trip took 6 hours and 20 minutes. I don't know how much time was traveled upstream or downstream. So since we cannot fill in those columns with a specific number, this is when we can use our formula to figure out an expression for time. Well, if I divide both sides of my equation by R, that's going to give me a formula for T. So distance divided by rate is equal to the time. So we're going to take that and we're going to plug that in here. Okay, so the distance, 95, divided by the rate, r plus 8, is the time that the boat traveled downstream, and then 95 divided by r minus 8 is going to be the time the boat was traveling upstream. And now, if I add those two times together, that should give me the total time of the trip, which we have as 6 hours and 20 minutes, which we've already converted to 19/3 hours. All right, so this is our equation that we're going to need to solve. So if you think back to solving rational equations, we need a least common denominator to get the fractions to cancel out. So our least common denominator is going to be 3 times r plus 8 times r minus 8, because we want each denominator to appear. Okay, so I'm going to go ahead and write that out to make sure it's clear. So 3 times r plus 8 times r minus 8. We're going to multiply that times both sides of our equation. And you want to make sure that you distribute. And then we also multiply that times the right side of our equation. Okay, so now when you multiply that through with the first fraction, I know the r plus 8s are going to cancel, so I'm left with 3 times r minus 8 times 95 plus, well, the r minus 8s will cancel in my second fraction, so I'll have 3 times r plus 8 times 95. On the right side, I see that the 3's are the only thing that cancel, so I'm left with 19 times r plus 8 times r minus 8. Okay, so we have a lot of terms here, but these expressions you've seen before. You just have to do it one step at a time to simplify. So we'll do 3 times 95, just getting my calculator handy here. 3 times 95 is 285. So we'll have a 285 times r minus 8 plus, then we're going to have another 285 times r plus 8 equals 19 times. Well, we can use FOIL to multiply those out, and once you do, you'd get r squared minus 64. Now I'm going to go ahead and distribute the 285. So we have 285r minus 285 times negative 8 is negative 2280 plus, now we have another 285r, but this time we'll have a plus 2280 equals, distributing the 19, we have a 19r squared minus 19 times 64 gives us 1216. Okay, so now I'm going to cancel out the 2280s. 285 plus another 285 gives us 570r. Equals 19r squared minus 1216. Okay, so I see I have a quadratic equation. So I'm going to move everything over to the right side so that I can get 0 on one side and then use my quadratic formula. So I'm going to have 0 is equal to 19r squared minus 570r minus 1216. Now, this is something I'm going to try It doesn't always work, but I would be curious if 19 goes into all of our numbers. It's possible that you have a math problem that, doesn't work out so nicely, but often there might be something where the numbers work out and things can be simplified. So if you check, 19 actually does divide all of these terms. So I'm going to go ahead and divide everything by 19 just to make our work more simple. So we end up with 0 is equal to r squared. 570 divided by 19 is 30r. And 1216 divided by 19 is 64. All right, so at this point, you can use the quadratic formula or you can factor it. This will factor into an r minus 32 times an r plus 2. Again, quadratic formula is fine to use if you prefer it. If you can factor it, sometimes it's quicker, but either method is fine. So I factored it, so now I'm using the zero product property and setting each of my factors equal to 0, and I need to solve. So first I get r is equal to 32, and in my second equation I get r is equal to negative 2. But remember that r represented a rate, so this cannot be the case. R cannot equal negative 2. So that means that our answer is going to be 32 miles per hour must be the speed that the boat was traveling on its own if it were in still water. Okay, let's go on to our last example. Alicia's car traveled 360 miles, averaging a certain speed. If the car had gone 4 miles per hour faster, the trip would have taken 1 hour less. Find the average speed of the car. All right, well, we're going to be using distance, rate, and time again, so I'm just going to write the formula to have it for easy reference. And remember that we've already solved it for t, so if we do distance divided by rate, that would give us time, just in case we're going to need that. And let's write our table. So we have a distance column, a rate column, and a time column. Okay, so in the rows, we're going to specify what are the two differences in how she was traveling on the trip. Okay, we know that she traveled a total of 360 miles. If the car had gone 4 miles per hour faster, the trip would have taken 1 hour less. Okay, so let's, we may want to say when she was traveling the slower speed, and then when she was traveling the faster speed. Okay, well, we don't know what the speed of the car was, so we're going to let that be r. Okay, so the average speed of the car, we're going to let that represent r. Okay, so when she was traveling initially, okay, we know that she traveled a total of 360 miles. Now, since they tell us if the car had gone 4 miles per hour faster, so meaning if it traveled r plus 4 miles per hour and went the 360 miles at that speed, the trip would have taken 1 hour less. Well, I don't know how many hours it took when she was going her slower or her initial speed. So we're going to use the expression t equals d over r. So we'll have our distance, 360, divided by r. And I know that if she went faster, that time, 360 over r, would have been 360 over our rate, which is r plus 4. I know that that time would be the same as the slower time minus an hour. Okay, so let's write that in an expression. So the slower time, 360 over r, would equal the faster time, 360 over r plus 4, plus an additional hour. Okay, so let me try to get that off our screen. So this is going to be our equation that we need to solve. So like the last problem, what we need to do is get our least common denominator, which is going to be r times r plus 4. So we're going to multiply both sides of the equation by that expression. Okay, we're going to do the same thing on the right side. Let me get that off again. Okay, so on the left side, the r will cancel, and we're left with 360 times the quantity r plus 4. On the right side, you need to make sure that you distribute to both terms. The r plus 4's cancel out, and we'll have 360r plus, and now we have 1 times r plus 4, so nothing cancels out with that one. Okay, so now I'm going to distribute the 360. So we have 360r plus, now we need to do 360 times 4, and that's 1440, equal to 360r plus r squared plus 4r. Okay, when we subtract 360r from both sides, they're going to cancel each other out, so we can subtract over 1440. So 0 will equal r squared plus 4r minus 1440. Okay, so to solve this, we can use the quadratic formula. If you can factor it, that's good. That would be fine too. But let's do quadratic formula this time. So a is 1, b is 4, and c is negative 1440. So that means our solution, r, will equal the opposite of b plus or minus the square root of b squared, which is 16, minus 4 times a times c is going to be negative 1440, divided by 2 times a. Well, a is just 1. So we end up with a negative 4 plus or minus the square root. Under the radical, you should end up with 5776 divided by 2. Well, 5776 is a perfect square, and it's equal to 76 divided by 2. So now we come up with our two answers, negative 4 plus 76 over 2, and that simplifies to 36. Or we can have negative 4 minus 76 over 2. Well, this is going to be a negative number, and since this represents r, we cannot have a negative rate. Okay, so it looks like we have our answer. The average speed of her car was 36 miles per hour. So she was not going very fast at all.